Hey friends, did you know that you can reliably load balance your network traffic across multiple Azure regions? You can do it with the Azure Cross Region Load Balancer using a single static public IP address. Mahip Deora is here to show me how it works today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. Today we're going to use the Azure Cross Region Load Balancer. We're here with Mahip. How are you?
I'm doing good, Scott. How about you?
I'm excited to learn all about how to load balance this traffic and remember the OSI model that I learned in school that I don't think about every single day.
Correct. Yeah. No, I'm excited to share with everyone Azure Cross-Region Load Balancer. But I guess before we get into it, I think you brought up the OSI model. I think it would be good to just, understand what are the different levels of OSI and where all these different features could fit in. What do you think
Right.
about that?
Yeah, I think you're right because there's 7 layers, but we don't really need to think about seven. Usually, when
Correct.
I simplify the OSI model in my head, I think about the physical stuff. There's a wire, and then like the transport layer, TCP, and then I think about the higher level stuff like HTTP. So one way for us to maybe think about it would be to ignore all 7 layers and really think about just layer 7, HTTP, host headers, and things like that, stuff that humans can look at, and then layer 4, which is kind of like TCP that I don't always look at. Is that a reasonable analogy?
Yeah, no, I think that's a perfect way to put it, right? Not all the layers are incredibly important in our world today in terms of networking.
Hmm.
But the two that we should focus on when it comes to load distribution and things such as that are layer 7, as you mentioned, HTTP web traffic, and
Mhm.
then layer 4, which is more, TCP, UDP traffic that, certain applications may also require.
So when I think about load balancing at the when I make app services, I usually think about HTTP and host headers. It's very basic and it has to crack open the packet all the way up to HTTP. And I will go and say, oh, you asked for AzureFriday.com. It's over there. Or maybe I'll use something like Azure Traffic Manager or more recently Azure Front Door. But this is something different and it's going to be better performance at a different layer.
Yeah, correct. So the two products you brought up, Azure Traffic Manager and Azure Front Door, they're excellent products. And what we've introduced now, and I can share my screen to show you an overview,
Hmm.
is Azure Cross Region Load Balancer. And each of these products aims to tackle a different networking pain point. And going back to the OSI model, Azure Front Door is our layer 7 offering, while Azure Traffic Manager is DNS based. And a component that we were missing was Azure Cross or the layer 4 layer level. And that's where we developed Azure Cross Region Load Balancer. Cross Region Load Balancer is a global layer 4 load balancer in which customers can easily distribute traffic globally with ease and fast performance, all using layer 4 capabilities.
So before Azure Cross Region Load Balancer, how did I find myself as a request from a client? How did I find myself routed to a public load balancer?
Correct. So before we introduced this feature, right, a common pattern that we saw was customers would attach their public load balancers to solutions such as DNS based, where they would, ping the DNS name and get one of the IP addresses that were attached to that DNS solution. But some of the issues they started to notice was if one of their backends became unhealthy or if there was some unexpected issue, DNS caching was causing issues where new traffic would still be sent to that unhealthy endpoint. And customers were coming to Azure asking for a more global layer 4 solution that could really help them build scalable applications across the globe to help them meet their ever growing demand.
The issue of it sticking, why do applications stick like that? I think we've all seen that. We want it to be not cached, but we also want it to instantly notice that something has gone down and be routed elsewhere. And that may not be a reasonable expectation.
It's trade-offs here and there, right? The benefit of caching is that the more an IP is looked up, the faster that the name gets resolved. The con there of course, as I mentioned, is if one of the endpoints becomes unhealthy in that cache, until that cache is cleared or that IP is popped off, new traffic could be sent to that unhealthy endpoint. So it's a trade-off. It's an interesting trade-off with the caching, right? You have numerous gains, but there are also very apparent trade-offs that you have to sacrifice in order for those gains. And again, cross-region load balancer was really aiming at solving that DNS caching issue that I mentioned before.
All right. So we're operating at layer 4, the TCP layer. We're not thinking about HTTP traffic, whatever traffic I'm sending, as long as it's going over TCP. In this example, you picked a random high port. Azure cross-region load balancer then does the right thing. And it does that based on my IP address, the client.
Correct. So the way we distribute traffic is through a 5-tuple hash. Um, Essentially, what it does is we don't inspect the incoming packet.
Hmm.
It comes in, Azure Load Balancer looks at a few pieces of information quickly. Source ID, as you mentioned, what is the destination IP, and then the port, among a few others. And it then decides what is the best backend resource to send to. Something like a layer 7 load balancer would you have the ability to inspect the packet, maybe do something like packet or heading based routing. That has its benefits, of course, but one of the trade-offs there is then, your packet is being inspected at the load balancer layer, which can cause some performance issues. With something like a layer 4 load balancer, because it's passed through, it is lightning fast in terms of traffic going from source all the way to destination.
Interesting. Okay. So this is a logical networking layout that really represents, boxes and lines, traditional layout. This makes a lot of sense to me. But when I think about global cross-region load balancing, I usually think of a map of the earth. And I think about like the fact that AzureFriday.com runs in a data center in Chicago. And when I have people visiting from Europe or from Africa, I want them to have a great experience wherever they are.
Yeah, of course. So let's take a example here, and I think this example is really going to help illustrate what is cross-region load balancer. Is it a logical component? Is it a actual piece of software that's running in one data centers? Let's help our customers and users understand that a little bit
Okay.
more.
All right.
So in this example here, I have two regional load balancers, one deployed in Africa and one deployed in the west coast of North America. And if my user is right here in Europe, right, they are going to send traffic to Azure Cross Region Load Balancer. And what we are going to do in the background is when traffic comes into the Microsoft network, we are going to figure out what is the most optimal route the customer's traffic needs to take such that they hit the closest regional load balancer to them. So after a customer sends their traffic to the cross region load balancer, we run our proximity and routing algorithm, and we determine that the load balancer that they should be sent to is the one in Africa, given their proximity to it. So traffic is then sent there, and then return traffic goes directly to the customer. Scott, that's something I really want to stress here is that your return traffic isn't going to go back the same route as incoming traffic. It is going direct to the customer. So that is just something I wanted to call out for us.
Okay, so then I have two questions then. First, I know that there's not yet an Azure data center floating on a ship in the center of the Atlantic. And you've put a cloud around that, which means that that's a logical thing. That's software-based networking. That's magic. That's the magic of cross-region load balancing, right? That exists kind of everywhere and nowhere.
Correct. I couldn't have said it any better. Azure Cross Region Load Balancer isn't running in one data center. And that is the beauty of this product. This product is running on tens of data centers across the globe. So your global IP address is being advertised across the globe. And if something happens in one geo, it isn't going to impact your performance in others. Because as we said, this feature is logical. It's running on multiple data centers. And that was the point trying to illustrate with it being in the Atlantic is that
Right.
This isn't something like the regional load balancers, which are tied to one region. This is
Right.
running cross region, as the name would say.
And then when you say your IP address, you don't mean your meaning, my non-technical parent or me, the browser user. You mean me, the Azure Friday developer. I have azurefriday.com. It has a public IP address. So your IP address being advertised is really my application. When I ping azurefriday.com, it's going to go and terminate at a particular Azure data center, in my case, Chicago. That's going to then be advertised everywhere. So then when someone wants a route to, in this case, the United States, Azure Cross-Region Load Balancer could send it to the one in Chicago or the new instance of Azure Friday that I'll fire up in an African data center and do the right thing.
Correct. That's exactly it. And it really is based on where your users are. So, as you said, yours is to really signify the app developers or the owners of these applications. And with Cross Region Load Balancer, where no matter where your users are, you can be ensured that our geo-proximity algorithm is going to send them to the most optimal path to the regional load balancers.
Okay. But you mentioned the freshness issue and the issue that things might necessarily, hang and get stuck somewhere. You've determined the correct route in line 3 there, and you're going to return your traffic
Mhm.
there. Do all subsequent ones always go through the cross-region load balancer? And how quickly can it notice when a backend goes down?
Yeah, so great questions. So on the first one about substantial or sequential incoming packets from the user, if it's part of an existing connection, then yes, it will take the same route. If it is a net new traffic or connection that's being established, it will be rerun through the hashing algorithm. 99 times out of 100, you'll end up at the same regional load balancer. In the off chance, let's take the example as we have an existing connection running, and that's going to hit our data center here in Africa. And let's say something happened to our application, unfortunately. There was a hardware issue, it could have been a software issue. Something happened that took down our application here in Africa. Next time a user tries to establish a connection with cross region load balancer, we are going to again run our proximity algorithm, figure out what is the most optimal route. But a crucial part of that is we know what are the healthy backend instances of your load balance or your deployment, and we will only send new traffic to those healthy instances. As soon as one of those healthy instances becomes unhealthy, we will automatically stop sending new traffic to it, and it will continue that way until that regional deployment resumes its health status.
Very cool. Okay, can I see a more complicated example maybe on a different map that tells me more?
Yeah, exactly. So let's take this example here. It's very similar to the example we previously talked about. We have two regional deployments, one here in Seattle and one in South America. Our user is based out of Texas. They send traffic to the global load balancer. Again, we run our algorithms, routing algorithms, geoproximity. We figure out that the optimal load balancer is the one in Seattle. They get sent to that, return traffic comes back. Now, let's say the customer, in our case, or the application owner, is noticing a lot of traffic in the East Coast or maybe in southern United States, and they think it's a worthwhile investment to spin up another deployment in the Midwest. So now when the user sends a new connection, again, we're going to run our algorithm. And our algorithm this time is going to say, hey, this new deployment that we opened up in the Midwest is the optimal choice for this user. So the customer is going to get sent to that. And Scott, one of the beauties I want to share here is that the customer, when they were sending traffic to one in both cases, they were sending it to the exact same IP address. The customer had no idea that the backend regional load balancers were shifted, which ones scaled up, which ones scaled down. All customers see is that one global IP address, and that's their gateway into your application. You, as the application user, can scale your backend deployments up and down with zero interruption to your end users.
There you go. And that's the magic of layer 4. And that's why you really want to have a multi-layer strategy when you're putting together an application that is global like this, and why
Correct.
this is so powerful and so transparent to the user.
Correct. Yeah, and that's the beauty. And that's what we've been seeing our customers use this for, as well as when they have deployments across geos. The pain point, aside from DNS, is they have IP management overhead. They have tens of IPs to manage, making sure that customers are, given the correct IP address to them. That's a lot of overhead that a customer has to manage. If they had a single entryway into their application, all they need to do is manage the backends and not really worry about, is my customer pointed to the correct IP address? Because it's, again, a single gateway into the application.
Very cool. So briefly, as we're running out of time, let's take a look real quick at the portal and see how easy this is to set up before I learn how to go and implement this
Yeah,
myself.
sounds good. So over here in Portal, I have a cross-region load balancer deployed. If we look at its backend pool, we can see two cross-region load balancers. We can see their name as well as the IP addresses of them. And if I take the front end IP of my global load balancer, and if we just do a ping, which I have right here, we'll see that I'm being sent to the regional deployment in West US, which I'm based in Seattle right now, so that is the most optimal load balancer to me. But let's take the example in this case where something happens to our West US 2 or West US deployment. Again, it could have been a hardware issue, software issue, application issue. Something happened. In our demo case, Scott, I'm just going to stop the VM for demo purposes
Yeah,
to
that's a little
simulate.
aggressive, but it happens. It
Yeah,
happens, right?
yeah, just to
So,
simulate that the load balancer or my deployment is shutting down.
okay.
So each of my regional load balancers has one VM for this demo. So as soon as this VM shuts down, my regional deployment in West US will be completely unhealthy. No new traffic can go to it. What Azure Cross Region Load Balancer is doing in the background, every 5 seconds, it's pinging both of my regional deployments and it's asking a very simple question. Are you healthy? Should I continue sending traffic to you? What's your status? And it takes that information in part with its routing algorithm to really decide, again, only sending traffic to the most optimal route for customers.
Okay, and
So
it's
as we
determining that using layer 4 exclusively. Typically, a health check that I would do it as an application developer is at a URL at layer 7 using HTTP. It's not doing a ping, though. What is it doing over TCP to determine health?
Correct. So we have some internal logic that is doing these helps. And something I do want to mention is these help probes on the global layer, they're automatic. Customers don't need to configure them. They're automatic, out of the box. And this is not an additional layer that customers need to worry about is, did I set my health checks correctly? This is done
Gotcha.
for customers as a managed service.
That's
So
cool.
as we can see here, my VM has shut down, which would mean that my West US deployment is unhealthy. So now, if I try to refresh my ping, we'll
Oh,
see that my response is now hello world from West Europe, which is my second regional load balancer that I had connected to my global load balancer. So, Scott, as we can see, through that single endpoint, I didn't really need to worry about, oh, am I pointing to the right IP? I have a unhealthy IP. I don't know what to do. I can't access my application. Azure Cross Region Load Balancer handled all of that under the hoods and made life easy for both me and both the application developer as well.
that's so cool. I love a failover demo. I just do. And the fact that it's the same IP address and that it's done at the IP layer and it's not a DNS thing, and it's transparent,
Yeah.
yeah, I think is wonderful. Layer 4. So how can I learn more about this and set this up myself?
Yeah, definitely. So I would encourage everyone to take a look at our documentation. It goes through, more in depth about some of the topics we've covered, as well as how routing is done, some of the benefits we see, such as client IP preservation. And something I like to highlight as well is we recently GA'd this product a few months ago. And as part of our GA from public preview, we now support IPv6, floating IP, among others, which our customers can read about in our public documentation. We also have tutorials to help you kickstart your deployment of cross-region load balancer, as well as examples and best use cases that we've seen.
Very cool. Well, thank you so much for sharing this with us.
Yeah, of course. Thanks for having me, Scott.
All right, I am learning all about the Azure Cross-Region Load Balancer today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.